The Voyager 1 space probe introduction. Voyager 1 is one of the most remarkable spacecraft in human history. Launched by NASA on September 5, 1977, it was the first probe to leave the heliosphere and enter interstellar space. Its mission was originally to explore Jupiter and Saturn, but due to the successful completion of its tasks and proper operation of its systems, Voyager 1 continued beyond the solar system, becoming the farthest man-made object from Earth. This probe not only expanded our knowledge of gas giants and their satellites, but also provided unique data on the limits of the Sun's influence. In addition, it carries the golden record, a message to extraterrestrial civilizations containing sounds, images, and scientific data about the Earth. In this video, we will look at the history of the mission, scientific discoveries, technical features of the spacecraft, its entry into interstellar space, cultural significance, and the future of Voyager 1. History of the creation and launch of Voyager 1. The Voyager project was developed by NASA in the 1970s to explore the outer planets of the solar system. Due to the rare planetary alignment, once every 175 years, it was possible to use gravitational maneuvers to visit Jupiter, Saturn, Uranus, and Neptune with a single spacecraft. Launch. Voyager 1 launched on September 5th, 1977 from Cape Canaveral on a Titan I rocket, 16 days after Voyager 217. Initial objectives: to study Jupiter and Saturn, their satellites and rings. Features of the trajectory: a faster route allowed it to overtake Voyager 2, we will talk about it later, and to be the first to reach the outer planet 7. Studies of Jupiter and Saturn-Jupiter, 1979, discoveries. Active volcanoes were discovered on Io, the first evidence of geologic activity beyond Earth. Jupiter's thin rings and 2 new satellites, Thebes and Metida, were found. Detailed images of the Great Red Spot, a giant storm raging for hundreds of years, are obtained. Saturn, 1980. Major achievements: study of the structure of the rings, including the discovery of shepherd satellites that form gaps in the rings. First detailed images of Titan, Saturn's largest satellite, with a dense atmosphere similar to ancient Earth. After the flyby of Saturn, Voyager 1 headed towards the borders of the solar system, as its trajectory did not allow it to visit Uranus and Neptune. Voyager 2 did. Going beyond the heliosphere, one of the main objectives of Voyager 1, after the completion of planetary exploration, was to study the heliosphere, the region where the solar wind dominates. 2004, crossing the shock wave, the boundary where the solar wind slows down. 2010, registration of zero solar wind speed at a distance of 113 AU from the Sun Day. 2012, exit to the interstellar medium based on plasma wave data, although the direction of the magnetic field did not change. As of 2025, Voyager 1 is more than 163 AU, 24 billion kilometers, from Earth and continues to transmit cosmic ray and magnetic field data. Technical features of the apparatus design: 10-sided body with a 3.66 m diameter antenna, 3 plutonium, 238 radioisotope thermoelectric generators, RITEGs. Original power 470 W, now 68% of original. Scientific instruments: cameras, shut down in 1990 to conserve energy. Magnetometers, plasma detectors, spectrometers, some still working. Communications. The data rate is 160 bps due to the huge distance. NASA's long-range space communications network is used to receive signals. Golden Plate. A message to extraterrestrial civilizations on board Voyager 1 is fixed a gold-plated copper plate with a diameter of 30 centimeters, containing greetings in 55 languages, including English. Sounds of the Earth, ocean sounds, bird song, human voices. Music from Bach to Chuck Berry. 116 images, DNA diagrams, landscapes, human anatomy. Earth's coordinates relative to pulsars. The idea of the record belonged to Carl Sagan, who saw it as a symbol of the unity of humanity. The cultural and scientific significance of the mission Pale Blue. In 1990, Voyager 1 took the famous picture of the Earth from a distance of 6 billion kilometers, where our planet looked like a tiny glowing dot. Carl Sagan called this photo a symbol of human humility. Impact on science. First evidence of volcanism outside the Earth, Io. Data on the structure of the heliosphere and the interstellar medium. Technological legacy. Mission proved the possibility of long-term operation of vehicles in deep space. Current status and future of Voyager 1 energy. RITEGs are gradually losing power. It is expected that by 2030, there will not be enough energy to maintain communications. Recent data. The probe transmitted anomalous signals in 2024, but engineers were able to restore operations. Future path. In 40,000 years, Voyager 1 will pass 1.6 light-years away from the star Gliese 445. Conclusion: Voyager 1 is not just a spacecraft, but a symbol of the human quest for knowledge. Its mission has changed our understanding of the solar system and inspired generations of scientists. Even when its communications are cut off, it will continue its journey through interstellar space, carrying a message about Earth to the depths of the galaxy. Research prospects. Analyzing data on the interstellar environment. Preparing new missions, e.g., the Interstellar Probe. Voyager 1 reminds us that mankind is capable of going beyond the ordinary, leaving a mark on the history of space. Voyager 2 is one of the most successful spacecraft in history, having made an unprecedented tour of all 4 giant planets in the solar system. Launched by NASA on August 20th, 1977, before Voyager 1. It became the only probe to explore Uranus and Neptune, as well as the first to transmit detailed data on these distant worlds. Unlike Voyager 1, which after Saturn headed toward the edge of the solar system, Voyager 2 continued on to Uranus and Neptune, giving mankind its first close-up images of these planets. Today, nearly 50 years after launch, Voyager 2 continues to operate in interstellar space, transmitting unique data about the space environment beyond the heliosphere. In this piece of video, we'll look at the mission's history, key discoveries, technical features of the spacecraft, its entry into interstellar space, and its cultural significance. History of the creation and launch of Voyager 2, the Voyager project, was originally conceived as part of the Mariner program to explore the outer planets. However, due to the rare planetary alignment, once every 175 years, NASA designed the mission with the ability to visit all 4 gas giants with one vehicle. Launch. Voyager 2 launched on August 20th, 1977 on a Titan I rocket, 16 days ahead of Voyager 1. Initial objectives: study of Jupiter, Saturn, Uranus, and Neptune. Trajectory peculiarities: due to a more complicated route to Uranus and Neptune, Voyager 2 flew slower, but this allowed it to perform a grand tour of all 4 planets. Studies of Jupiter and Saturn-Jupiter, 1979. Discoveries confirmed the existence of Jupiter's rings, discovered by Voyager 1. Studied the satellites Io, Europa, Ganymede, and Callisto, discovering active volcanoes on Io and cracks in Europa's icy surface. Took the first detailed images of the Great Red Spot. Saturn, 1981. Major accomplishments: discovered complex ring structure, including spiral waves and Shepherd satellites. Explored Titan's atmosphere, confirming the presence of a dense nitrogen atmosphere. Discovered new satellites, including Pandora and Prometheus. After passing Saturn, Voyager 2 headed toward Uranus, while Voyager 1 left the ecliptic plane. First studies of Uranus and Neptune-Uranus, 1986, discoveries. First images of Uranus and its satellites, 10 new images in all. Discovered a magnetic field tilted 60 degrees about the axis of rotation. Studied the rings of Uranus, discovering 2 new ones. Photographed the satellite Miranda, which has an unusual relief checkerboard. Neptune, 1989, major accomplishments. First and only images of Neptune and its satellite Triton. Discovered the Great Dark Spot, a giant storm similar to the spot on Jupiter. Detected cryovolcanoes on Triton spewing nitrogen and dust. Confirmed the existence of Neptune's incomplete rings, arches. After passing Neptune, Voyager 2 headed toward the edge of the solar system.
Going out into interstellar space like Voyager 1, Voyager 2 studied the boundaries of the heliosphere, the region dominated by the solar wind. 2007, crossing the shock wave, the solar wind deceleration boundary. 2018, exit into the interstellar medium, confirmed by plasma spectrometer data. Year 2023, continues to transmit cosmic ray and magnetic field data. As of 2025, Voyager 2 is more than 133 AU, 20 billion kilometers, from Earth. Technical features of the device construction: similar to Voyager 1, 10-sided body with 3.66 m antenna, 3 RITEGs, original power 470 W, now 45%. Scientific instruments, still operating: magnetometer, cosmic ray detector, plasma spectrometer, disabled. Cameras, 1998. Infrared spectrometer, 2016. Communications, transmission rate is 160 bps. NASA DSN network is used. Golden record, a message to extraterrestrial civilizations like Voyager 1. Voyager 2 carries a gold plaque with greetings in 55 languages, sounds of the earth, thunder, bird song, heartbeats, music, Beethoven, Chuck Berry, coordinates of the sun relative to pulsars, scientific and cultural significance, unique data on Uranus and Neptune, the only close images so far, confirmation of Triton activity, cryovolcanoes, study of heliospheric boundaries, comparison with Voyager 1 data, Inspiration for new missions, e.g., Trident to Triton. Current status and future energy. Communication is expected to break by 2030. Future path. In 40,000 years, we'll pass within 1.7 light-years of the star Ross 248. Conclusion: Voyager 2 is a legend in space exploration. Its mission not only expanded our knowledge of the solar system, but also showed that humanity is capable of exploring even the most distant worlds. Perspectives. Analyzing data on the interstellar medium. Preparing missions to ice giants, Uranus orbiter. Voyager 2 will remain a symbol of scientific progress even after its signals no longer reach Earth. Conclusion: the Voyagers have not just accomplished their mission, they have exceeded expectations. Originally designed to last 5 years, they have now been in operation for 48 years, becoming the most distant man-made objects. Their legacy: basic knowledge of the outer solar system, proof that humanity can explore interstellar space, a symbol of hope for contact with other civilizations. Was it worth it? Absolutely. Without Voyagers, we would still not know about the icy volcanoes of Triton, the oceans of Europa, or the boundaries of the heliosphere. Their mission is one of the greatest triumphs of science.